Hello and welcome to a new series of videos where I actually start to use mass language to implement uh, some kind of features, ideas. Generally, I start to use language and see how it feels like and what else we might need to do in a previous series on the compiler programming, which will still go on as I have things to change and improve. But in order for us to actually do anything useful with language, there needs to be some kind of standard library. And I guess the most fundamental thing that we'll need to be able to do is to get some memory from the system. So today I want to work on the small library that will allow me to get virtual memory directly from the system, whether it is Windows or Linux. macOS is actually on the same, more or less has the same interface as Linux in this respect, so shouldn't be a problem, but I'll focus on Windows and Linux, which is something I can test easily with obviously this being Windows, and then I have this WSL virtual machine that I can also test things on. Now, I'll try to not touch the compiler unless I will run into the wall, but the idea is to try to start using language as it is and see how it feels like. So the first thing is I will need to figure out how do I organize the modules, and it is hard to say right now. Maybe that's a good organization, maybe it's not. But let's say I'll create a new file, we'll call it virtual memory. And so it already brings a question like, what is the convention for naming the files? Is it going to be dashes, underscores, uppercase, lowercase? So that's, yeah, something to consider. I think I'll go with lowercase and underscores, but maybe that's not a good idea because, for example, the types are right now named in title case, so I don't know. Anyhow, the basic operation that we will need to do is we will need to allocate a chunk of memory, and we will need to also have a sort of a way to specify what kind of permissions are for this memory. Like, is it readable? Is it writable? Is it executable? Something along those lines. So let's get to it. So let's have allocate function, and we need to figure out what it will accept. And I guess the first thing to consider here is how do I deal with signed and unsigned integers, because one of the interesting things about the language is that by default it doesn't define signed and unsigned types. Instead, we just deal with an integer type that is defined to be 2's complement, but whether you treat it as signed is unsigned, something that depends on the operation. And here it is a question of whether I should explicitly say that I want unsigned types, or do I want the signed one? I think I do want to specify that this is an unsigned size of allocation, and it should be possible to cast one to the other, so you should be able to provide literals here. So let's go with this option. So we'll say size is U64. And as I said, we also need to specify permissions. Okay. And permissions is, let's say that this would be permissions. And what is permissions? Well, here we ran into the first sort of a problem, I would say. And that has to do that there is no real way to specify flags currently in the language. How can I work around that? Well, I can sort of use the C++ way, more or less, where I define a struct with the fields, and then I add helpers that would allow me to operate on that struct. I guess that's something I can try to make work. So let's say this will be a C struct, and then inside of it we'll have raw or bits is an I64. Okay. We'll need to export that. It also needs a dot here. Okay, now if we targeting Windows, then we need to do one thing. If we're targeting Linux, we'll need to do another thing. For now, we will focus obviously on Windows because it's easier, because that's the main system I'm used to. And here we need to figure out what exactly we will return. Well, we will return a pointer to void, more or less. I still haven't decided if I want to have some kind of type that will be more safe than void. Like void is something that is zero sized and anything can be assigned to void, but maybe there is also a good idea to have a type where you explicitly don't know the size of. I don't know. And maybe that's not assignable to anything. Okay, but anyway, let's focus on task at hand and see what else is problematic. So here, we also need to define right. So flags are actually going to be very interesting in general, because I have this nice syntax, as you can see here, for accessing enum values. But there is an interesting problem with when you have a compound expression. Maybe I'm going ahead too far, but you will see in a moment. For now, maybe I can just do more of a C-style thing where you say read is well, is permissions, and then here I need to provide bit, so we'll say 0b 001, and then we'll have write, and that will be like this, and execute is going to be like this. Right, so that should probably work. Maybe this alignment is better. I don't know. I also need to decide what is the style I want to have here. But anyhow, So I have these structs, I have these flags, even though they are not super nice to deal with. And how do I want to handle this? So I think there is a bitwise AND and bitwise OR. Yes, they are. And we can probably define OR one, the AND we don't really need. And we can say that if we have X, which is permissions, and Y, which is permissions, we'll get back more permissions. And what we need to do is pretty straightforward. We just need to return a new thing, which will have X bits or Y bits. Ideally, I would want to have a better way to define this, maybe some kind of common library to do this, but this is sort of exactly why I'm doing what I'm doing right now, is to realize what are the problems I will have once I start using this language properly. Because it's one thing to imagine something in my head and thinking, oh, this would be a great feature, this would be a great feature. It's quite another to actually try to do it. Right. Okay. So that is nice. Also, another thing that I see is as well that I probably want to have compile time version of it, because yeah. So this is something interesting as well for me to think about, because right now this OR will actually result in runtime call to a function, and inline calls is something I need to think about it. There are still macros, but they will probably not survive for too long. But it's a story for compiler programming stream for now. No, will not be considered concerned with efficiency, except for maybe making a comment about that, saying speed. This should be an auto inline or explicitly inlined function. Right. Okay. So that seems reasonable. I'm not sure if that will actually work. And then here we accept, right? And now I can go to my C code and look at this stuff. So this is more or less the code that we will need to port. But for now, right. So another thing is that the API also accepts address, which is pointer to void equals 0. So by default, we want the address to be chosen by the system, but you should be able to provide the address that you want. And we also will run into the problem right now that I need to figure out what do I do about errors, because this function can actually fail. And that is another area that I will apparently need to think about it, but for now I'll just make a comment to do figure out what is the strategy for errors in mass. So this already has been super informative for me, but I wanted to do it in a video so you can see me flail about and realize how undeveloped language is still. But it's good learnings, Okay. Now we have this. We need to go to Win32 and we need to just have another external API call. Okay, this would be virtual Alec. And as for the actual signature of virtual Alec, maybe we should go to MDN or MSDN, sorry. MSDN, virtual Alec. Great, virtual Alec. So that's what we will need to add in here. And great. So it wants LP void address. Great. Address is pointer to void. And this also returns a pointer to void, as I mentioned. Address, size T. I assume 64-bit system, so size T is U64. And then we have allocation type. Dword is an S32, I believe. So I can verify that by just searching for dword. Yes, but that's not exactly what I'm looking for. MSDN data types dword. I definitely don't want it to be in German, so let's do this in English. Right, and the word 32-bit unsigned integer. Okay, well, we can do that. That's not a problem. Allocation type is U32, and then protect is also U32. In reality, both of those things are enums, but there is also no real way to define enums as of yet, so I'm just gonna stick with this kind of stuff. And I also will need to have, so I should have closed my virtual Alec thingy because I need to have these things. Mem commit a0x. Let me just grab these. Mem reserve. So I think that these kind of libraries that just drop the system stuff, they should be as close in the API to what the system actually provides. So if these things are global constants, then maybe they should stay global constants, because that's what you'll have in examples, and the closer you can sort of transplant from the stuff you see in the tutorial or something to what you see here, the easier for it will be to actually for people to use this. Now, this another thing that I'm starting to sort of maybe not enjoy so much is this exports here, that I need to list all of them, and this list will become amazingly huge. In reality, for this module, I can probably just do this, and because by default everything is exported, unless you say that nothing is. At least I believe that's what the logic is, but we'll quickly discover if that's not the case. So let's continue on this stuff. Memory protection constants. Yes, that's what I want. Page execute 0x10. Page execute read. All right. Yeah, now I remember that. That's not as simple as I thought, because you can't just have it as flags in the permissions here, because not all combinations are actually available, and some of them are like even more specific, like something like write copy, right? So that is something to consider, and maybe it's not even a good idea to have this kind of wrapper around the virtual memory, or maybe it is. I don't know. I'll just maybe then keep it like this. Read, write. Read, execute. So I definitely need read, I definitely need read, write. I definitely need read, execute. I probably also will need read, write, execute. I also need to decide if I want this to be in title case or not, but ignoring that, now that means that we actually don't need this stuff. And in here, we will have something like 1. So yeah, I'm just emulating enum, which is not great. I definitely need to figure out how to create enums. Maybe that will be the next video for the compiler programming, but let's just continue here, because I want to have something working. Okay, so read, none, read, write, execute. Fine. Okay. So we need page execute, read. So this is just execute. I don't actually care about it, but that's fine. Execute, read. I also need execute, read, write. Read, write, which is 80. There will also be no access. So let's do that. Read only, read, write. Good. Page read only, and read, write. I think that is enough. Yeah, the others are a lot more niche, let's put it that way. So these are the constants, that's good. They are just i64, so I should be able to OR them, and I should be able to then convert them, I guess. We'll see what issues will lie for us when we actually start to use this stuff. But for now, we'll just say virtual Alec, address, size, and then I need to say mem commit meta reserve, right? So I would say that something like what is it called again? Allocation type. Yes. So say allocation type Right, so allocation type, and this is actually going to be a constant because we will commit and reserve in one go, I guess. But that's something I might want to put in API later. But for now, let's just say mem commit or mem reserve. Actually, that would be maybe I want to using in here. Let's hope that even works. So there's going to be lots of stuff that might just start failing randomly, and then we'll have to get back into compiler to fix it. Or more likely I will work around the issues, but for now I'll just try to write it as I would want to write it, and then we'll go from there if we have to work around some kind of issues, or I have to work around. Okay, address size, allocation type, and then you also need the Win32 permissions. Okay, and then Win32 permissions is going to be, well, we'll say it like this. If permissions is read, then what? Then this is gonna be page read only, I guess. Else if, so I don't have a switch statement, which is something I'll need to think about because it's kind of awkward. But let's just go through this, read write, and this is going to be page read write. And well, let's just kill one of them so I have to type less. But I need to definitely think about how to handle this switch statement. Read, write, execute, and then page read, write. Here actually, let's do none as well. Is none, then so this would be page no access, I think it was called. Yeah. Well, if I miss up something, that's also good, because I'll get some errors, and we need to test those as well. Okay, and else, so this is actually very interesting. So right now I'll have to put something in here, but I just introduced yesterday a never type, which means that the function does not return, and I need to actually annotate it, use it to annotate the asserts so that the compiler knows that asserts never return, and it should sort of prune this branch from the type checking and allow me to not return something of type permissions. But anyway, and here I'll just say to do use an assert, and that is changed to have never type. And never is something that is from TypeScript, how it's called, and in some functional languages. In something like C, I think there's like called no return, which is an attribute, or something like this. But yeah, the idea is that the compiler should just know that this fails. So assert false and say unreachable. Okay, unreachable. Great. Then virtual Alec, and here I'll just return 0, although this branch will not be taken at all, so I don't even care if that's compile. I think that should be all, but I probably messed up multiple times, so we will see. And I also want to actually do something with that. So for now, I will use external tests to deal with this. How do I say something like standard library or something? I will also need to think about how to test this better. But for now, I'll just use C interface to test this. So let me copy paste some code from here that I'll actually be able to work with. That sounds good. So it should support virtual memory allocation. That's fine. That's fine. This returns. I should return. Oops. We can actually stress test our compiler and say infer the return type of this function, which is a nice thing that I can do. And here I would say that VM is import std. Yeah, that's a bit awkward. Virtual memory.mass. Is this how I import this? I actually don't need to say mass. I don't know my own language. But that's what happens when you work too long on the compiler side of things. Okay, and I would say VM allocate. Let's just allocate a single page. Right, and I need to say permissions. So VM dot read write. Sounds good to me. And then I would say void star memory is checker. Here I need to actually change the type. And so we have memory. We need to say that we need to check that memory is available. And then we also need to try to write to that memory. So maybe something like U8, oops, U8 star memory star is 42. And we also should be able to read from this memory. So memory 0 is 42. Right, let's first actually let's run all the other tests for me to verify that exporting actually works if I don't specify the export correctly. Okay, what's the problem here? Right. So that needs to be like this. Okay, so all the other test cases work. That means I can just focus on this one and see what kind of errors I made. Field read write does not exist on type module. Well, you are correct there, compiler. So let's export it. And yeah, I definitely already becoming not a fan of this. I don't know what is a better alternative to having to specify this stuff, but yeah, not a fan. I can actually, well, no, let's continue just using test, even though it's a bit slower than it could be. Expected a value to be static and 331. So no, it's in here. So apparently I cannot do that, which is annoying. So to work around this, to do, or more like fix me, this should work. But it's, yeah, we are not going to get distracted by the compiler stuff. But it's a very good learning that this does not actually do what I think it will. Or more precisely, I cannot apparently construct a struct in a constant manner, which makes no sense. So it's definitely a bug. I can try to do this. That should work, I guess. But we'll see. We'll see. Maybe I have more things to fix. Okay, and now it is more unhappy. It is unhappy in here, I guess. No. 1031. No. It is still very much unhappy here. Am I defining struct incorrectly? Oh, I do. No, I don't. Yeah, no, I don't. So that was actually not what I was thinking it was. I forgot my own syntax. Again, it actually needs to have this. Let's try again, shall we? Uh, 728. So yeah, we made progress, but not much. Well, that is something. I guess we are going to debug compiler a bit. At least I will quickly take a look and see if that's something super stupid and I can fix, or it is something that is way more fundamental and I have to defer to later and figure out something else to do. Okay, so handle function call arg. Arg is null. That is not great. Not great at all. What is I? I is 0. That is even less great. Handle function call. So we somehow got to here, and right, so this is sort of, yeah, it's actually a very easy fix, so I will do it. And this comes back to how to handle errors, because right now the way they handle it in the compiler, I'm not particularly happy, but I'm not sure how to do it else in C without going completely insane or have lots of boilerplate. So what's missing here is just I'm not checking that we had an error, and I'm trying to proceed with the logic. I think this should actually print us the correct error instead of crashing. Okay, that is a perfectly reasonable error, and probably something that I indeed screwed up. Yeah, as you can see here, I screwed up and I didn't use an S in the permissions. So let's try all of that again. Could not find matching overload for a call. That is interesting. And I know why that happens. But the fix is sort of kind of not particularly pretty. So what I have to do is I have to do this, I think, and specify that this is the type of this. Maybe like this is nicer to look at, but in reality it doesn't matter. And they will both do exactly the same thing. So I don't know. Let's keep it that way. I also might decide that I want to support this stuff or something. I don't know. That is a stylistic choice, and I'm still thinking about it. This should help, I think. But again, this is something for me to think about. I still don't have a matching overload for call. Address, size. So let's I need to figure out which exact argument actually fails, and that's something for me to definitely to consider. Huh. So address, size. This is super confusing. Does it not work like this? Yeah, I cannot compare structs. Amazing. I mean, that is a fixable problem. That I can do. I can say that if I'm comparing permissions and y is permissions, then just do what? Well, do x bits is y dot bits. Let's see if that's going to help. So apparently now that doesn't work. 1421. It cannot do this. This is even more strange. Okay, right. That's another thing. Should be possible to define this quality. Great. Yeah, it is very annoying on one side, but I think it's really great that I'm finding all of this stuff. Right, so I know what to fix. So I can't actually define this. I have to be like C and do this stuff, which is really not what you would want to have. But I just need to sort of move forward. Tuple does not have enough type items to match the thing it's assigned to. 521. Hmm, 512. What's it assigned to? It's not assigned to anything. Okay. I'm giving up on this, so I have a fix me, and right now I want to actually make this work. So we're going to do again, and then question just go the C way. This is just going to be like this. And then I don't need to do this nonsense. So let's see if that helps. Well, we are crashing, is what I have to say. So let's again quickly take a look in the compiler. That's interesting. I thought we are crashing. I'm thoroughly confused right now. So oh, yeah, right. I know what's happening. I'm pointing to the wrong function and it's just exiting the process. Okay. Let's try that again. Oh, all right. That is actually fine because I have all zeros here, so obviously this would fail miserably. Now I want to start slowly substituting these things and see which one was actually failing the type check. Okay, fine. Can I just do this? 496. This should work, I think. Okay. We still get 0, probably because it doesn't have mem commit or mem reserve. So is it the allocation type that makes you go boom? Okay, so it is address that is not assignable? Really? What? I think it has to do something with default arguments or something. So to do figure out why default argument address does not work. Let's just get rid of it for now and say we cannot specify the address. Okay, so that is at least working just fine. But all of this will fail miserably for Linux. So let's make that happen for Linux. Standard Linux. So I need to find the Linux syscall. So Linux map syscall. Whoa, that was bright. Let's get back to that. Much better. Okay, but that is not exactly what I want. This describes the syscall, but doesn't give me the number, right? Syscall table. Probably gonna be light again, so warning. And now it's dark. So mmap. It is a 9. Fine. We can have a map, a 9. And now we can use this stuff to figure out what are the arguments to it. So address, the same as in the Windows version. So address, and then we have length, so I'll call it size, 264. It's called length, so it's the same thing. Protection, which is an S32, or more like an I32 to be honest. And then we have flags, which also is an I32. File descriptor. File descriptor is an also an I32. And offset T, that is in 64-bit, will also be 64-bit, I believe. So offset is U64. Something along these lines. We need to export it. Okay. In here, we'll also need to have these constants. So let's do this one. And yeah, that's also not gonna parse. Now we'll need to define the same constants. So actually, let's maybe, on one hand, it's nice to have them by number, but on the other hand, I want to put the constants next to it. And of course, it doesn't say what is the value of those things. In this case, MSTN documentation was much better. So how can I figure this out? Well, find user include maybe name. Okay. So let's probably look at this thing. Let's open it in Vim. I haven't used Vim in forever, so what I want is these constants slash prot, which are not defined in here. Amazing. So that's very disappointing. Let me open another Ubuntu one, and we'll go to user include and just rip grep prot exec, something like define prot exec. Yeah, okay, great. 0x4. How hard was that? Prot exec 0x04, and I think I'll have to do the same thing here. And then prot read, I would assume, is 1, and prot write is 2, right? Is it the right? Is it like minus C10 or something? There's some way to specify the context for this thing, but I'll maybe do it some other way. Yeah, so I will write about write, and I probably write about read. Okay, so these are protections, and there is also none, which obviously is 0. Okay, that's fine, and I also need to have these map ones. In reality, I'm only interested in map private, I believe. Yeah, okay, so these are the ones I need. So map private. Let's do it like this, maybe. Right, so I want map private, map anonymous. Okay. Let's do the same rip grep stuff that we did. Map private is 0x02. Map unknown is 20. 0x20, and map no reserve, no array is 0x. Actually, I don't want no reserve probably, so let's remove this for now. So private and anonymous. This is what I want. Great. Let's try to make it work then. So I guess I would want to do the same thing and say sysmap. That's an address. And then we would have what we would have wrong thing. Just for reference, address. Actually, I need to put size in here and still check if it works. Address size, protection. So that's something we will need to do the same dispatch as this, but for now, let's start with just saying protection read and protection write. Prot, all right. And then we have flags. which is this map private, map anonymous. Okay, map private, map. Let's not do this. And then we need to have -1 here. And offsets, I think it's 0. Yeah, required by map anonymous. Great. So that seems reasonable. First of all, let's try again on Windows because I actually updated the size here. Okay, Windows apparently fails. 40, 32. So it does not know how to deal with I32 ors. So I guess here I don't need these. Yeah, I'll need to definitely think about more about how integers are dealt with, but that's a separate topic. Okay, all of this works on Windows. Now the question is, will it work on Linux? Let's see. Yes, that is not correct because it's a copy-paste error. Here it needs to have a pointer to void. Let's try again. Ooh. Oh, I think that is actually an incorrect assertion. But let's quickly take a look. Actually, I will not be able to see it here because it's on Linux. So what is triggering calling convention 786? 786. Yeah, that's just not correct. It should be less or equal to 64 bits. Because obviously syscall should be able to return a pointer. Okay. That is much worse. No, because it should be like this. Again. And here we go. Okay, so I still need to do this dance over here. To do the Linux permissions. And this one should be easier actually. Prot non, prot read, prot read, prot write, prot read, prot write, prot execute. And then prot none here again. Good. Let's try again. Prot. Probably called prot exec. Yeah. And now here we have problems. let's try this. Maybe that will work. Hopefully. Yeah. That is kind of annoying. I think I can do this. Now we are in real trouble. So what if I do it like this? Yeah, that just shows that I still have things to iron out with my integer handling. Definitely. Linux mass 1313. I just need to smack it into submission with casts for now. Okay, that is obviously terrible. Fix me figure out how to avoid these weird casts. Okay, but all in all, now I can allocate memory. We added a standard library. We found a ton of issues that need to be addressed. I'm pretty sure that a lot of them are pretty minor, but a lot of them are not so much. That have to do with sort of the semantics of language or casting rules and things like this. But this was pretty good. I'm really happy that I did this because now that allows me to know what to work on next. But that is all for today. Thanks a lot for watching if you stuck with me failing with my own language, and hopefully see you next time.